Okay, we're going to do another graph here. This one is given y equals 2x plus 1. And because of the form of this, because it's solved for y, I'm just going to pick some x values instead of both x's and y's. I'm just going to pick x's because it's a simple matter to substitute. Now, 0 is a great number to start with because it makes your math easy. This is 2 times 0 plus 1. So that we know that's a 1. So it's like we didn't have to actually do any solving on this one. Okay, let's pick another value. How about 2? Well, y would be 2 times 2 plus a 1, which is 5. Okay, and we can pick some negatives. How about negative 2, for example? Y is 2 times negative 2 plus a 1. That's going to give you a negative 3. So there's a negative 3. Okay, let's go over and plot these now. 0, 1 is right here. And let's see, 2, 5 is over here. Let's see. Let's see. 2, 5. Let's see. Where's my pen? Right here. 1, 2 over and up to 5. So that's actually all the way up here at the end. I need to put it there. Okay, 2, 5. And the other one, we don't really need it, but we can throw it in anyway. Negative 2, negative 3 is over here. And notice how they line up, even though I haven't drawn that line in yet. I'm going to do that now. See if I can get this to be nice and neat. Start down here. Oops. Oh gosh, that didn't go so well. Let's try it again. Let's see. Start here and take it all the way up here. Okay, that's about the best I can do right there. Okay, so there's my line, and again, I could extend it this way to come further down, you know, best I could like that. And we have another line. Every point on this line is a solution to the equation. You can pick off some if you can spot them. In fact, notice if I can trust my drawing, which I think I can, it looks like there's an ordered pair right here, which looks like it has the coordinates 1, 3. Okay, so the question is that a solution to the equation? Well, it should be because it's on the line. Let's check it. We have our equation, which looks like this. And let's put in, we have a 3 for the y and a 1 for the x. This right-hand side is 2, and 2 plus 1 is 3. So it does check. Look at that. Okay, so yeah, we do have the line here, and we can pick off all solutions along here, infinite number of solutions. Okay. Okay, here's another example. Y equals 3. And what you notice about this is that it's an equation. It's not just a number, it's an equation. Because we know that because it says graph. So we're assuming, and we're in 2 dimensions. We know that we're in the rectangular coordinate system. Graph this. Well, there's no x. So when you go to fill in your t-table with ordered pairs, you don't have a choice for the y. It says y is 3. You have to stick with that, no matter how many ordered pairs you find. Now, x, it doesn't show up in the equation. So that means it could be anything you want it to be. If it's not in the equation, then x can be anything. You can pick a 0, you can pick a 1, pick a 3. And if you come over to plot those, you'll have 0, 3, 1, 3, and 3, 3. Okay, so that was 1, 2, 3, and this is 1, 2, 3 in that direction. This is negatives in this direction. Okay, so I could continue with this. I could find more ordered pairs if I wanted to. Let's pick some negatives. We have a 3 for the y. How about a negative 2? So here's that point in here, right there. Whoops, I lost my point. I'm not sure why that happens, but anyway, I'll try it again. There it is. Okay, negative 2, 3. Those are the ordered pairs. Now, if you connect these with a line, I'm going to try to freehand this one. I don't like using that tool. It's kind of difficult, but if I go all the way across like this, now I know I missed a point there, but here, you just kind of keep it straight across. It's kind of difficult to keep it neat. Okay, there's the line. What you notice about this is it's unusual because it goes straight across left to right. It's an example of what we would call a horizontal line. And whenever you have an equation like that, y equals constant, and you see an x in the equation, it's a horizontal line. The fact is, y equals 3, notice it's 3 high on the grid. It started as y equals 3, and it's 3 high in the y direction. If you were going to graph, say, y equals negative 2, that would be negative 2 units down. And you would have something that looked like this. This would be y equals negative 2, and so forth. Sometimes the lines come in forms like 1 plus y equals 0. That you can transform to just read that if you just subtract a 1. And then you'll say, oh, that's y equals negative 1. So it's here, and it goes left to right. And that's y equals negative 1. All examples of horizontal lines. All right, now here we're going to do another example. This time we're going to graph with what are called intercepts. Now, an intercept is a point along either the y-axis or the x-axis. That's what an intercept is. Where if a line, for example, if I drew a line like this point right here is called a y-intercept. Okay, a y-intercept. This point down here would be called an x-intercept. Okay, now sometimes we refer to the actual number. In this case, it looks like if that ordered pair were, say, negative 3, 0, then we could refer to the negative 3 as the x-intercept or the ordered pair as the x-intercept. The y-intercept, in this case, it looks like the ordered pair, and you can test yourself on this. It looks like it's 0, 2. Sometimes we call the 2 the y-intercept. Sometimes we call the whole ordered pair the y-intercept. You got to be comfortable using both forms. So now, let's take an example if we wanted to use these points as part of our graphing procedure. Let's say we were going to graph, let's say we had 2x plus y equals 4, for example. And let's see. Okay, here we are, our next example. We're going to graph this using the intercept. So here's how it works. We have our t-table, and going to purposely pick x equal to 0 because I know that if there is a point along the y-axis, in other words, a y-intercept, then it will occur when x is 0. So I'm going to pick x equals 0 and see what that does to my equation. 0 plus y equals 4. That tells me y is equal to 4. Okay, so now I have the y-intercept. It's right here. 0, 4. Now, I could do the same thing to find the x-intercept, but this time I'll have to put y equal to 0 because if there is an x-intercept, it occurs along here. Okay, it occurs along here, the x-axis, and any point on the x-axis has y coordinate equal to 0. So I purposely set y equal to 0. And then I solve my equation. 2x plus 0 equals 4. That's 2x equals 4 and x equals 2, dividing out the 2. So I get a 2 here. I only need 2 ordered pairs to draw a line, and I have these 2, and they're both intercepts. So this is 0, 4, and this is 2, 0. So I'll put that over here. Find it. There's 2, 0. And then draw a line between them. Okay, pretty good. So that's graphing with intercepts. They can be easy to use. Notice when you're using zeros in your equations, the math is usually easier. So those are handy for us to work with. And in contextual problems, these are important points usually because 0 is always an important number in any application. 0 time, 0 money, 0 work, 0 product, 0. It's always a pivotal point in any application. So zeros are important in our applications, and they're important for the way we use them here because they're easy to, the graphing becomes easy with them. Okay, one more example here. This one, we're going to try to graph this. Notice it doesn't have a y in it. This is an equation with no y. One thing we might try to do is notice this. Same equation, just move that 3 to the right side. If we were going to make our t-table like so, we would have to have x equal -3 because that's what the equation says. X is -3. So you don't have a choice for those x's. They all have to be -3s. Now we don't need that many. If we take this -3 and put it into the equation, we get this. We're trying to solve this for y, but there's no y. That as long as this is true, which it is, -3 is -3, y could be anything. This we saw is called an identity. So no matter what I do, I'm going to get any value I want for the y for this equation. So I can pick a 0, I can pick a 2, about a -4. Okay, and we'll go ahead and plot these. -3, 0 over -3, 0 right there. -3, 2. Well, that's again over, but up to -3, -4. That's down here. Over -3 and down -4. Okay, connecting those with a straight line, best you can. I'm going to try this. Whoa. Oh, that was bad. Okay, let's try that again. Okay, not too bad. And then you continue upward like that. Okay, so we have a straight line. Supposed to be straight, but and a couple things we notice about is this is what's called vertical. Okay, it's an example of a vertical line, and they always have this form, x equals a constant. Always have that form. So whenever you see an equation like this, you know automatically it's going to be vertical line. So you don't have to spend a lot of time graphing it. Let's say x equals -2. Well, that would be over here at -2, straight up and down. Let's say x were equal to 3. Well, that would be over here at 3, vertically, straight up and down at 3. All the points along here, along that line, have x coordinate equal to 3. That's what this tells us. So that's important to remember about the vertical line.